Now let's just move on further towards the next theorem, which is theorem number 2, which says that if a transversal intersects the two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. So now we have to prove that if we have a transversal that is intersecting two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. So let us suppose if I'm just drawing a figure for this one, I'm taking this as nothing but A and B, and further I'm taking this as nothing but C and D. We have to prove that these are parallel to each other. And let us suppose if I'm just taking a transversal over here. Let us suppose if I'm just taking a transversal over here, which is nothing but called as P and Q, and it is intersecting it as R and S. So let us suppose if I'm just talking about this particular angle, means we have to prove that these two lines are actually parallel to each other. So let us suppose if I'm just writing the given condition, we have two lines A, B and C, D with PQ as a transversal such that the alternate interior angles are equal. So let us suppose if I'm just calling this particular angle as angle 1, I'm taking this angle as angle 2, I'm taking this angle as angle 3, I'm taking this angle as angle 4, and I'm taking this angle as nothing but angle 5. Let us suppose if I'm just taking this angle as angle 5, now such that it is given to us that angle 1 is equal to angle 4 and angle 2 is equal to the angle 3. This is a given condition to us because it says that a pair of alternate interior angle is equal. A pair of alternate interior angles is equal. So means if we are just talking about this one or this one, so there is one such condition in between the two. So let us suppose if I'm just taking or in between, this is or in between, that angle 1 is equal to the angle 4 or either angle 2 is equal to the angle 3. Now let us suppose if I'm just starting to prove what we have to prove over here. We have to prove that AB is actually parallel to CD. AB is parallel to CD. So let's just start the proof of this one. First of all, we know that according to the condition, let us suppose if I'm just taking angle 1 is equal to the angle 4 condition. If I'm just taking either we can take angle 1 is equal to angle 4, either we can take angle 2 is equal to angle 3. So let us suppose if I'm taking angle 2 is equal to the angle 3. So angle 2 is equal to the angle 3. This is actually a given condition to us because it says a pair of the alternate interior angle is equal to each other. Now furthermore, we can say that for A, B and PQ being the two intersecting lines, since they are intersecting lines, it implies that angle 5 should be equal to the angle 2. Why so? Because they are forming the vertically opposite angles, because they are forming the vertically opposite angle pair. They are forming the vertically opposite angle pair. Let us suppose if I'm calling it as 1, I'm calling it as 2. So from 1 and 2, what can we say? From 1 and 2, we can say that angle 2 is equal to the angle 3, which is equal to the angle 5, which implies that angle 5 is equal to the angle 3. Angle 5 is equal to the angle 3. Hence, what we are getting at the end, we are getting that this particular angle and this particular angle, they are equal to each other. So, if these angles are equal to each other, it implies that if angle 5 is equal to angle 3, they will definitely form a pair of corresponding angles. They are definitely forming a pair of corresponding angles, and since if they are corresponding angles, it implies that AB is parallel to CD by the converse of corresponding angle axiom because we know from the converse of the corresponding angle axiom, if we have any particular transversal in which a pair of corresponding angle is equal to each other, then it implies that the two lines are parallel to each other. So it implies AB is nothing but parallel to CD. So hence this is the proof of this particular theorem. This is all about the theorem that if a transversal intersect two lines such that a pair of alternate interior angle is equal, then the two lines are parallel to each other.